Welcome to teaching physics. So you already discussed about the potentials. So the meaning of potential you already know. A potential is the work done in bringing a unit positive charge from infinity to that point is termed as what? Potentials. Now let us pass on to one of the important concepts, that is equipotential surfaces. So what is the meaning of the equipotential surface? Equipotential surface. So what is this equipotential surface? Equipotential surface is the surface, and any surface which having a same potential, or we can say about the equal potential, then we can call it as an equipotential surface. Let us consider the one, a conductor. Okay, so the conductor. Potential of this at any point. So here, or we can say here, or we can say here, anywhere. The potential remains what here? The constant. Or we can, in other words, equal potential is termed as what here? Equipotential surface. So in an equipotential surface, what happens to the electric field? So here we have electric field. Okay. This is an electric field like this. Okay. This particular electric field is always, we can able to say, it is a perpendicular to the what here? To this surface. So the meaning of this equipotential surface, we can define in other words, a locus of a point. We can able to say like this, the locus of a water, the points in a medium, locus of a point in a medium, at which the electric potential due to a charge distribution is always considered as what here? C. That is also termed as what here? Electric equipotential surface. Now we have the number of examples for this equipotential surface. A conductor in an electrostatics is a best example for an equipotential surface. And there is a second example is an earth is itself is the water behaves as a what here? Equipotential. How we can say the earth is itself behaves as an what here? Equipotential. Now we have the earth is just considered as a water, one metallic sphere like this. It is just a metallic sphere. Then at each and every the point, the electric field is always the perpendicular to what here? This the surface. Therefore, the V1, so V, we can say, this is all potentials. Okay. This electric field and also this the electric surface is perpendicular to each other. So then the earth is also the behaves as a what here? Equipotential surface. Now these are the examples for this what here? The equipotential surface. And let us consider the one surface. So here we have the surface like this. So here is another surface. So here we have one. So the plate surface like this. So this is the first surface. This is called the second surface. This one is considered as what your third surface. And we have the electric field is like this in this direction. In this direction. So we can able to say this is uniform electric field. I can able to say this one, uniform electric field. The potential of the first surface is V1. Potential of the second surface is V2. Potential of the third surface is V3. So potential is due to uniform electric field is here. So here is an electric field. For a first surface, V1 is the what here? Potential. For all these points, you can take any value, the potential is becomes about here V1 only. For let us consider for a V2 surface. So the V2 is the potential here for a second surface. So here at any point V2 is the what here? The same potential, equal potential is there here also. And then here also it is the same as equal potential is there. It means that when the potential, these plates, what we have, it is very closer and closer and closer to each other. The electric field is goes on, what happens? Increases. And if it is far away from each other, so the electric field is goes on, what happens? Decreases. So this is due to what here? The electric equipotential surface, due to what here? Uniform electric field. So the first one is a uniform electric field. Uniform electric field. Electric field. Now in the same manner, I want to know about that for an isolated point charge. What is the potential due to the what is isolated point charge? Let us consider like this. Isolated point charge. Point charge. For an isolated point charge, what is the potential? So let us consider here is an what here, the Q I can even mention. Here is a one charge. As it is radius is goes on increases, okay, so just like this, okay. Then what happens? This is all electric field, uniform electric field. So you already know the one equation, how to find out the potentials. So we have V is equal to 1 over 4 pi epsilon naught Q divided by, what is that? R. Q is the charge here. V is the potential. R is considered as the distance, or we can say the radius of that. Now as the R is goes on increases, what happens to the potential? The potential is becomes what happens? Decreases. But it has a what here? Equal potential here, 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 anywhere at the point. So this is V is equal to Q divided by 4 pi epsilon naught R. As the radius is goes on increases, okay, the potential, what happens? It is decreases. This is how we can able to represent the equipotential surface for an what here? Isolated point charge. In the same manner, if there are two charges are there, let us consider Q plus, here also there is a Q plus, okay, same kind of or similar charges. Then how can you represent the equipotential surface for this? So this is how we can able to represent. Here also Q plus, here also the same or a similar kind of what here? Charge. I can able to represent like this. If for a dipole, okay, this is for a dipole. So two equal and opposite charges. Here we have plus and here we have what here? The minus. Then we can able to represent the equipotential surface in this manner. Okay, it looks like starting from the what here? This electric field is starting from the positive and ends in a what here? The negative. So this is what we can able to say about equipotential surface. The overall meaning of the equipotential surface is a surface which is having equal potential. So if you like my videos, please subscribe TGL Physics. Thank you.